Hello, good day everyone. Okay, nandito na naman tayo sa lesson natin sa differential calculus. So for today, let's discuss ito namang derivatives of other functions. So last time we have discussed yung mga derivatives ng algebraic functions, trigonometric functions. Ngayon naman, we will be discussing some other functions na importante sa pag-aaral natin ng differential calculus. And these are exponential functions, logarithmic functions, and then the hyperbolic functions, dadaanan din natin yan. But to give emphasis sa exponential and logarithmic functions for this particular presentation. Okay? So let's do a quick recap ng ating mga formulas, no? Ng derivatives. Just in case dun sa mga kakarating pa lang dito sa ating lecture, of course, we started by getting the derivative ng mga constant, no? Derivative ng constant, yan ay 0. Okay? Ano pa? Derivative ng sum, okay? With respect to x ng dalawang function, no? Of course, that will be the derivative ng first function plus the derivative ng second function. Okay? With the same or with respect to x. Okay? Then we also discuss yung the derivative naman ng product or yung product rule. Okay? That is the first function times the derivative of the second function plus the second function times the derivative of the first function. So ganyan siya, no? Then pang-apat yung quotient rule naman. Okay? So let's say u over v, no? And yung u and v, those are functions of x, ha? So this will be quotient rule, uh, denominator times the derivative ng numerator minus the numerator times the derivative ng denominator all over the denominator squared. Yan. So 1, 2, 3, 4. Yun yung mga basic natin. And fifth, ito yung ating general power formula. The derivative with respect to x ng function u, no? Na merong power. Yan. So, dito, kinukuha natin, binababa natin yung power niya, and then babawasan natin ng isa, no? Multiply natin yan sa derivative ng buong u with respect to x. Okay? Number 6, kumukuha rin tayo ng derivative ng mga radicals, no? Or square root. Let's say square root of u. Ganyan. So, ang formula natin dyan, 1 over 2 the square root of u, di ba? Then, multiply natin sa derivative nung nasa loob ng radical. Okay? So, ganyan lang naman siya, no? Yung mga basic. So now, and then we also discuss yung chain rule, ha? Na-apply na natin dyan. Importante yung chain rule. Ano pa ba? Yung mga implicit, yan. Makakatulong yan sa atin mamaya. Implicit differentiation, no? So, hindi na ngayon, using implicit, di na siya required kung naka-isolate yung y sa x or yung dependent variable sa independent variable. We can get the derivative implicitly dun sa ating function. So, chain rule, implicit differentiation, higher order, no? Na-discuss na rin natin to. Higher order derivatives, yung mga second derivative, third derivatives. Yan. So, ngayon naman, ang i-discuss natin is yung mga ibang functions, other functions aside from this 6 at saka yung mga trigonometric pala, no? Makalimutan ko, siguro number 7, yung derivative ng sign, no? Sign ng isang function, di ba? With respect to x, yan ay cosine ng function na yon times the derivative ng function na nasa loob. Okay, yung cosine, derivative with respect to x ng cosine u, equal naman yan sa negative sign, di ba? Sin u, tapos derivative ulit with respect to x. We also have yung tangent naman. Derivative with respect to x ng tangent ng isang function, equal yan sa uh, secant squared u times the derivative with respect to x. Hindi na natin isosolve pa yan. Memorizing nyo by heart yung ating mga formulas. Let's add yung cotangent naman, no? Kabaliktaran ng tangent. Uh, Derivative of cotangent u with respect to x, yan naman ay negative cosecant squared u times du dx. Then, 11, derivative with respect to x ng, ano pang susunod? Secant naman. Secant u, equal naman yan pag secant, secant u. Secant u tangent u times du dx. Okay. Number 12, dito na lang sa taas. So, derivative with respect to x ng cosecant u. Yan naman ay equal sa negative, no? Negative cosecant u, cotangent u, multiplied by du dx. Okay, so yun yung mga basic formulas na nadaanan na natin aside from using the chain rule, implicit differentiation, and the higher order derivatives. Gagamitin natin yan, no? Sa applications. But now, let's discuss yung derivative ng tinatawag natin exponential functions. So, meron tayong dalawang klase ng exponential functions. Ito yung e to the x tsaka yung a to the x. Ibig sabihin ng e to the x, meron tayong e, yung Euler's number. Remember or recall that diniscuss na natin yung e. It is the limit, di ba? It is the limit as n approaches infinity of 1 plus 1 over n raised to n. So, definition niyan. Okay. Also, yung ating Euler's number or yung e, it is also equal to the limit as n approaches 0 ng 1 plus n raised to the 1 over n. No? Diniscuss na natin yan doon sa special limits. Okay, so definition yan ng e. Gagamitin natin yan to derive itong formula natin for the derivative ng e to the x. But for now, tatandaan lang muna natin yan, itong definition na to. Okay? So bakit nga ba natin kailangan pag-aralan pa itong mga exponential functions na ito, no? Pwede namang polynomial na lang tsaka trigonometric. Ang sagot is marami sa mga natural phenomena, no, nagbabago-bago according sa mga patterns aside sa polynomial and trigonometric functions. So ito nga yung other functions like exponential and logarithmic. So magiging useful para sa inyo or sa atin na malaman kung paano kunin ang mga derivatives ng mga functions na ganito. Okay. Two common functions na nag-occur na medyo familiar tayo ay yung exponential and logarithmic. For example, let's say we want to examine yung rate of change ng bacteria colony populations, yung growth rate, then yung tinatawag nating exponential growth, tsaka yung decay. No? Meron din tayong tissue growth rates sa medical field, ginagamit din natin yan. Tsaka yung mga seismic differences ng earthquakes. So ilan lang yan sa mga fascinating topics na ginagamitan ng exponential and logarithmic differentiation. Kaya importante na malaman natin paano kunin itong derivative ng mga to. So let's start by deriving yung formula natin ng derivative of e to the x. Okay? So when we say e to the x, yung ating base, yung ating base ay yung e. Tapos meron tayong exponent na x, no? So let's say we have a function y is equal to e to the x. So again, para makuha natin yung formula natin yan, gagamit tayo ng steps na ginagamit natin to derive yung mga formula ng polynomial functions. Okay, ulitin ko lang ulit, and then gagamitin na nating basis to sa pagkuha ng mga susunod natin mga formulas. Okay? So let's start by adding yung delta y tsaka delta x natin dito sa equation. So maaalala natin that ito gagawin nating y plus delta y is equal to e to the x plus delta x, no? So pinalitan ko lang yung y tsaka yung x na meron ng mga differential, no? Next, syempre, yung next step natin, nililipat natin yung y dito sa kabila, no? Yan. Lipat natin yan dyan. So, ang mangyayari, magiging delta y na lang to is equal to e to the quantity x plus delta x, di ba? Minus y. Now, papalitan natin yung y na yan ng original equation. Yun yung step na lagi natin ginagawa. Okay? So this will now become equal to delta y is equal to e to the x plus delta x minus e to the x. So kung mapapansin ninyo, wala na yung y. Ang natira na lang is yung ating delta y plus yung mga e na merong x at delta x. Isi-simplify pa natin para mas makita natin mabuti yung itong exponent na nakikita natin dito sa e na to, no? Pwede pa natin yan paghiwalayin. Using the law of exponents, this will now become delta y is equal to e to the x, no? E to the x times e to the delta x minus e to the x. Okay, that is law of exponents na ginamit natin dyan. We can now factor out e to the x. Therefore, delta y is equal to e to the x, right? Multiplied to e to the delta x minus 1. Yan. So now, syempre sa pagkuha ng or pag-derive ng formula, we will divide this by delta x para makompleto natin yung expression dito uh, sa left side, no? So we will divide this by delta x will now become delta y over delta x. It is equal to e to the x times e to the delta x minus 1 divided by delta x. No? So obviously, hindi ko na sinama yung e to the x kasi magiging constant na yan later. No? Ang concern na lang natin sa paggawa ng limit nito is yung mga delta x. No? Yan, ito. Tsaka ito. Kaya ito namang e to the x na to, ano na siya, pwede na natin siyang i-isolate. Kaya nandiyan lang siya sa harapan kasi factor lang siya. Okay? So, ang next step natin is to get the limit. Okay? So, y prime or dy dx is equal to the limit as delta x approaches 0 ng ating delta y over delta x. And of course, yan nga no, dahil constant na yung e to the x, labas na siya dyan sa usapan na yan, it will now become e to the x times the limit as delta x approaches 0 ng expression na ito. Okay? Yan. E to the delta x minus 1 all over delta x. Okay? So, medyo masalimuot ito, no? Kasi kung mapapansin natin, napakahirap i-substitute ng 0 dyan kasi sa numerator, if we are going to substitute delta x directly na, so ang lalabas dyan ay e to the 0, which is equal to 1. And 1 minus 1 is 0. Divided by 0 will be indeterminate. Kaya naman, isasolve pa natin muna ulit ito using substitution or representing the value ng nito, no? So, we will use, scratch tayo dito ng konti. Okay. para lang ma-recall natin, no? Again, kanina diniscuss ko na that E is equal to the limit as n approaches infinity ng 1 plus 1 over n raised to the n, or E is also equal to the limit as n approaches 0 of 1 plus n raised to the 1 over n. Okay? So, tatandaan natin ito kasi gagamitin natin ito mamaya. Okay? Sa pag-solve nitong expression na to. Kasi merong e to the delta x. No? Ngayon, papalitan natin yung expression na yan kasi nga mahirap siyang i-solve using representation. No? We are going to let n equal to e to the delta x minus 1. No? Para mawala na yan muna sa paningin natin, palitan natin ng n. Tapos, ilipat ko yung minus 1 sa kabila, magiging n plus 1 na to, di ba? Or magiging 1 plus n, tapos ma-isolate ko yung e to the delta x. Diba? Ganyan. Okay. Tapos para makuha natin yung delta x, gagamit tayo ng logarithm or ln. No? Ln of 1 plus n is equal to ln of e to the delta x, right? And dahil ganyan, we now have ln of 1 plus n equal to delta x. So yan na ngayon ang ipapalit natin dito, no? Para mawala yung ating delta x na yan. Pero once na magpalit tayo ng variable, kailangan yung ating limit papalitan din natin, no? So therefore, when delta x approaches 0, ano ang nangyayari sa n, no? Yung n natin, pagpalitan natin ng 0 to, n approaches, tama, 0, no? Kasi papalitan natin to ng 0, magiging 1 minus 1 yan. Kaya naman, n will be approaching 0. So now, this is ready to be replaced. Okay? So, i-write na muna natin ulit, ha? Yung ating dy dx is now equal to e to the x, kopyahin ko lang muna, times the limit as n approaches 0. Pinalitan ko na yung ating limit, no? Tapos dito naman, ano ang lalabas dyan? This will be, ito yung gusto natin palitan ng n, no? So this will now become n over, yung ating delta x is ln ng quantity 1 plus n, right? So ganyan yung itsura niya. So huwag kayong matakot dito guys kasi mukha lang siyang mahirap pero madali siyang gawin. Okay? Yan. So meron tayong limit as n, tapos meron tayong ln. Although pwede na nating i-substitute yung value ng 0 dyan, 0 over 0 pa rin yung lalabas. Kaya, para ma-solve natin yan, no? Para ma-solve natin yan, i-divide natin lahat yan by n. Okay? So our derivative expression will now become equal to e to the x times the limit as n approaches 0 of, so i-divide ko lahat sa n, this will now become equal to 1. Ito naman sa baba is 1 over n times the ln of 1 plus n. No, you see the pattern? Yan. Now, recall, during your algebra class that a ln of b is equal to ln of b raised to a. Ganyan din ang gagawin natin dito. Ibig sabihin, kung ito yung aking b, ito yung a, ilalagay ko ngayon yan dun sa exponent niya or sa power niya. Kaya we can now rewrite this expression ng ating uh, dy dx, no? Okay, sulat lang muna natin yan. Dx. No? Therefore, yung ating dy dx will now become equal to e to the x times the limit as n approaches 0 ng 1 over the ln of 1 plus n raised to the 1 over n. No? Lagyan pa natin ng intensity ng konti. ln of 1 plus n raised to the 1 over n. Oops! Sinong kamukha? Kung mapapansin natin, medyo naawig na siya dito, no? Medyo naawig na siya dyan. Ngayon, once na na-divide na natin, pwede na nating i-evaluate yung limit. Huwag kayong matakot guys sa ln kasi pwede naman yan nasa labas. Okay? So, paano gagawin yan? This will now become equal to e to the x, okay, times. So, pwede tayo mag-evaluate ng limit ng mga quotients. Parehas nating i-evaluate yung limit. So, limit as n approaches 0 ng 1, okay, divided by ln, okay, ln times the limit as n approaches 0 ng 1 plus n raised to the 1 over n. Oops! Anong napansin natin? Itong expression na to ay equivalent pala dun sa taas, no? So, palitan ko ng pula para mas makita ninyo. Sabi, limit as n approaches 0 ng quantity 1 plus n raised to the 1 over n. Okay? So, ito ay kamukhang kamukha nito. Okay? Therefore, we can further replace itong nasa ilalim ng definition ng E. Therefore, yung ating dy dx is equal to e to the x, di ba? Times. Ano ang limit ng 1 as n approaches 0? It is equal to 1 kasi wala naman tayong papalitan dyan. And dun sa baba, lumalabas na ln of e yung ating pinalit na expression dun sa limit, no? Yan yung ating definition. Gagamitin pala natin yan. Okay? And we all know that 1 over ln e is also equal yan sa 1. Kaya ang natira na lang sa atin is e to the x. Ibig sabihin, burahin ko lang to. Therefore, the derivative with respect to x ng e to the x is equal to e to the x. Right? Ibig sabihin, e to the x lang din pala yun. Isa to sa mga pinakamadaling sagutan na derivative sa calculus. No? So, very, very easy. Kasi pag nakita mo yung e to the x, makopyahin mo na lang siya. And ang magiging problema na lang is yung pagkuha ng derivative ng exponent. Okay? So, pakitandaan itong ating formula. No? Napakahaba ng ating dinerive, pero worth it yan kasi mas naintindihan natin yung concept ng e or exponential function. So, what if yung ating x ay palitan natin ng function of u, no? E to the u. So, therefore, yung ating sagot will be e to the u times du dx. Okay? So, nadagdagan naman yung ating formula, guys. Okay? Yan. Let's try to solve an example. Pwede ba? Hindi. So, for example, we would like to find the derivative, example lang ha, derivative with respect to x ng e to the 3x, di ba? Ganyan. So, ang sagot natin dyan, gagayahin lang natin to. e to the 3x times yung derivative nung 3x which is equal sa 3, di ba? So, times 3. Therefore, equal na yan sa 3 e to the 3x. Okay? So, ganun lang siya. Ano pa? So, let's try find the derivative with respect to x of e to the x squared. Ba, yan, matindi to. Kasi, naka-exponent pa. No? Pero, as simple as our formula, we can solve this by using the proper formula. E to the x squared times the derivative of x squared, which is 2x raised to the 1. No? Therefore, it is 2x e to the x squared. Okay? Ganyan lang siya. Ganyan lang kunin yung ating uh, e. So, ano pang example natin dyan? So, what if pinakuha sa atin yung siguro next na natin. So, bago tayo pumunta doon sa ln, no? Another example, let's say y is equal to e to the 3x. Ganyan. Find y double prime. Yan. Ito, higher order derivatives. So, in this case, um, kukunin muna natin yung y prime, no? So, yung ating y prime, first derivative, equal yan sa e to the 3x, kakopyahin lang natin, times the derivative ng 3x. Ano yung derivative ng 3x? Yes, 3. Therefore, y prime is equal to 3 e to the 3x. Okay? Tapos, pag kunin natin yung derivative naman ng first derivative, ganun ulit. Y double prime is equal to 3 times the derivative ulit ng e to the 3x. So, ulit lang ulit. This will now become equal to e to the 3x times 3 na naman ulit. Therefore, y double prime is equal to 9 e to the 3x. So, yung isa naman. Let's say y is equal to e to the x squared. Find y double prime. So, ito medyo mahirap-hirap na kaunti kasi uh, meron siyang x squared. So, let's find y prime muna. So, we have e to the x squared times derivative ng x squared which is 2x. Simplify muna natin para maganda tignan. We have 2x e to the x squared. Now, let's try to get the derivative nito. No, dahil y double prime na yan, gagamit tayo ng power formula. So, sa power formula, sa product rule pala, sorry, we have the first function and yung ating second function. Okay? So, sabi, first function times the derivative ng second function. Anong derivative ng second function? E to the x squared times 2x ulit plus the second function, e to the x squared times the derivative of the first function which is 2. Simplify natin ha. This will now become y double prime. So ito ay nagiging 4x squared e to the x squared plus ito ay 2 e to the x squared. Okay. So pwede pa nating i-factor out yung 2 e to the x squared. Therefore, y double prime is equal to 2 e to the x squared times this will be 2x squared plus 1. Okay? So, ganun lang siya. Medyo madaling sundan itong e to the x kasi nga, ulit-ulit lang siya. Okay? So, that's it. Let's move on to uh, the next or function. No? So, yung ating next function, burahin ko na muna to, is to find the derivative ng logarithmic or ln ng x. Okay? So, ang ln ng x kasi, uh, tinatawag nating natural logarithmic function. Okay? So, fairly straightforward yan. Maganda to kung merong mga graph, meron kayong graphing calculator, pwede nyo magamit yan. So, yan. Kunin natin yung derivative ng natural logarithm, no? So, dahil alam na natin na yung derivative nga ulit ng ano, no? Derivative with respect to x ng e to the x ay equal yan sa e to the x. Consider the function, let's say we have y is equal to ln of x. Sabi ng ln, natural logarithm. Then, of course, wala naman tayong formula dyan and I will not use yung ating basic or fundamental derivation, yung may delta y at saka delta x. No? In this case, I will use e, no? Itong exponent natin, to get rid of base ln. Paano natin gagawin yun? We will raise lahat ito sa base ng e. So, paano yun? Gagawin natin e to the y is equal to e to the ln of x. Pwede yan, no? Yan. Wala naman na bago doon sa expression, same lang siya. Naka-raise lang yan sa e. So pagka ganyan ang expression, yung ating left side magiging e to the y na yan, and yung ating right side magiging x. Okay? Kasi mag-cancel yung e tsaka yung ln. Okay? So in this case, pwede natin gamitan ng implicit differentiation. When we say implicit differentiation, so kahit na ganyan yung itsura ng y, gagamitan natin siya ng i-derivative natin siya or i-derive natin siya. So, paano to sagutan? Ano nga ulit ang derivative ng e to the x? It is equal to e to the x. And the derivative ng with respect to x ng isang function na nakaraise sa e, it is e to the x times du over dx. In this case, ganito rin sa y, no? Ang derivative niyan ay e to the y times dy dx is equal to the derivative of x with respect to x, which is also equal to 1. Okay? Therefore, yung ating dy dx, yan yung ating gustong mahanap talaga eh, no? Will be equal to 1 over e to the y. Oops! Ano nga ulit yung ating e to the y? Di ba ito yung ating e to the y, no? Tama ba? Or pwede rin na ito yung ating gamiting e to the y, no? Yan, ito. Yan. So, pwede pala nating palitan yung e to the y na yan. No? Yung ating dy will now, or dy dx will now become equal to 1 over x. So, meron na naman tayong bagong formula na sa pagkuha ng derivative ng natural logarithm of x. Equal lang pala yan sa reciprocal ng x. And of course, using chain rule, the derivative, generalize muna natin. Therefore, the derivative with respect to x of the natural logarithm of x or ln x is equal to 1 over x. And kung gagamit tayo ng chain rule, the derivative with respect to x of the natural logarithm of a function of u with respect to x is equal to 1 over u times du dx. Let us illustrate this with some examples. Okay, nadagdagan na naman yung ating formula. Ay, pangit. So, I usually memorize. So, I'm used to memorizing itong may u. Yun yung mini-memorize natin. Kasi parang meron siyang chain rule. So, let's try what if yung ating function f of x is equal to, let's say, ln of x squared plus 4. Sample lang yan. Find f prime of x. Yan. Okay. So, using our formula, di ba? ln of u, yung ating u dyan, itong function sa loob, no? Yan yung u. So, gagamitin lang natin yan. Solution natin, f prime of x is equal to 1 over u. Ano yung u natin? X squared plus 4 times the derivative ng x squared plus 4, which is 2x minus 1 plus 0. Simplify lang natin yung ating f prime of x, equal na yan sa 2x over x squared plus 4. Ganun lang siya. Ganun siya kadali. Pag basic yung mga example, madali lang siya. Okay. Siguro magbigay pa tayo ng isa pa. F of x, let's say y naman. Y is equal to ln of uh, ln of cosine x plus 3x. Ganyan, squared. No? So, sa pagkuha ng y prime, ganun pa rin. Y prime is equal to 1 over, sulat lang natin maayos, 1 over itong buo, cosine x plus 3x squared, times the derivative ng nasa loob. Ano ang derivative ng cosine nga ulit? Ang derivative ng cosine ay negative sine of x plus derivative ng 3x squared, it is 3 times 2x. Okay, sobrahin mo natin ito. Ayusin natin. Okay, simplify natin ha. Yung ating y prime is now equal to 6x minus sine of x. So, inuna ko lang muna yung 6x kasi pangit naman kung negative yun sa harap. Pero sa baba, cosine x plus 3x squared. So, ganyan lang siya. No? Next, derivative of log of x to the base of x, or to the base of, yeah, ulit. It is the logarithm of x to the base a. Yan. So itong logarithm na to, it requires yung pag-recall natin ng mga algebra. Pinag-aralan na natin using the properties of logarithm. Okay? So, ang pinakauna na dapat nating maalala dyan ay yung paggamit natin nitong formula na to. Yung ating logarithm of x to the base a, pwede kasi natin yan i-rewrite into the logarithm x base c, this is another number, over logarithm of a to the base c. Ibig sabihin, pwede tayo mag-introduce ng ibang base, okay, para maging fraction to. For example, log of x to the base 5. Pwede natin yan gawing logarithm of x. Let's say, gusto kong base ay 2. Ganyan, 2. Over log of 5, 2. At napakaganda kung ganito yung gagawin natin. Let's say log of 5, okay, log of x to the base 5 can be written as log of x to the base e over log of 5 to the base e, which can be also written as ln of x over ln of 5. So with this, kumbaga, meron tayong logarithm of x to the base a, pwede palang maging ln yan. No? Which alam na natin yung formula, di ba? Ng pagkuha ng derivative ng ln. And of course, yung nasa denominator naman ay constant lang yan kasi ln 5, uh, log of any number, constant lang yan. So, pwede natin yan i-factor out. Okay? So, di pa natin nasagot yung formula, no? Therefore, if that's the case, let's say we want to find uh, the derivative, no? So, let's say we have a function, the derivative with respect to x of the logarithm of x to the base a. So, paano yan? Equal daw yan sa derivative with respect to x of ln of x over ln of a. Yun yung sinasabi sa algebra or pagkapalit ng mga variables. And in this case, pwede natin i-factor out yung a, ha? This will now become 1 over ln of a times the derivative with respect to x ng ln of x. And di ba alam na natin yung formula na to? Therefore, the derivative of the logarithm of x to the base a is simply 1 over x, or para mas maganda, kasi finactor out na natin yung ln a, so 1 over ln a times 1 over x, which is also equal to 1 over x ln, oops, ln of a. And kung yan, no? Yun siya. Kung i-generalize natin, the derivative with respect to x ng logarithm of a function u to the base of any number is equal to 1 over u ln of a times du over dx. So, tatandaan natin ito. Yan. Ano example niyan? Bigay tayo ng example. Let's say we have a function y is equal to logarithm of 5x plus 1 to the base 9. Yan, yung gusto natin sagutan. We want to find the derivative or the y prime. So, ang pagkuha niyan ay gagamitin natin yung formula. Identify muna natin yung u. Yung ating u ay 5x plus 1. And yung ating a ay 9. Therefore, y prime is equal to, gagayain lang natin to, sagutan natin, 1 over u ay 5x plus 1, kinokopya ko lang, times ln ng 9 times derivative daw ng 5x plus 1, which is equal to 5 plus 0. Ganyan na siya. Therefore, it is equal to 5 all over quantity 5x plus 1 times ln ng 9. Ganun na siya. No? Medyo simple lang siya. For as long as alam natin yung formula at alam natin yung mga basic na derivatives ng polynomials and trigonometric functions, medyo makakasabay tayo dito. No? And let's go on to the logarithmic differentiation. No? Kahit na yung phrase na logarithmic differentiation, medyo, ang tunog kasi nito medyo intimidating. Ano lang naman to? This is a four-step method na to help us take derivatives and then prove another derivative rule. So yung process na ito, it uses another one of long forgotten logarithm rules. So ano ba yung ibig sabihin niyan? It says that ln of x to the n is equal to n times ln of x. So ibig sabihin pala, kung meron tayong power form or meron tayong exponent sa loob ng ln, pwede nating ibaba yung ating exponent n doon sa labas ng ln. No? Tatandaan natin yan. Kasi, uh, kumbaga, mapapadali yung ating pagdi-differentiate kasi alam na natin yung kung paano kunin ang derivative ng ln of x. So ito guys, wag natin kakalimutan yung pag-roll down ng n. No? In other words, yung exponent dun sa ating logarithm, we can roll it down in front ng logarithm, parang magiging multiplier siya. No? Yan, actually na-discuss na natin yan kanina. Subukan natin dito. No? Suppose that we like to find the slope, no? For example, I think problem, no? Find the slope of y is equal to x raised to the cosine of x. Yan. X na, tapos naka-cosine of x pa. At x is equal to 1. Okay. Medyo sa una nakakatakot yan kasi x na sa baba, tapos may exponent pa na x. Okay. You will need to evaluate the derivative when x is equal to 5. Para mahanap natin yung derivative na to, we will apply the power rule by bringing cosine x pababa dun sa ating exponent, then babawasan natin ng isa. So, yan yung pinaka-obvious na mali. No? For example, uh, y prime is equal to uh, cosine x, di ba ganyan? Usually ganito gagawin eh. X to the cosine x minus 1. This is wrong. No? Maling approach ito. Yan. Ang gagawin natin dito is buti na lang meron tayong logarithmic differentiation na pwedeng tumulong sa atin para ma-differentiate yan. So, ang una natin gagawin is to take the natural logarithm para bumaba yung cosine. Okay? So, paano yon? We will take the natural logarithm of y and then, ganun din sa kabila, natural logarithm ng x raised to the cosine x. Pagka ganito, pwede na natin ngayon ibaba yung ating exponent. This will now become ln of y equals cosine of x ln of x. So, parang ganyan na siya. And then, we can now get the derivative. No? So, when we get the derivative with respect to x ng ln of y is equal to the derivative with respect to x ng cosine x ln of x. So, dito sa una, implicit, no? Kasi naka-ln yung y. Pero madali naman yan kasi 1 over y lang yan, y prime. 1 over y times y prime. Then sa kabila naman, medyo masalimuot kasi meron tayong product rule na gagamitin. Anyway, solve pa rin natin. So ano ang derivative ng ln y? It is 1 over y times the derivative of y with respect to x, di ba? Is equal to, kukunin natin yung derivative natin dalawa. First function, cosine, no? Cosine ng x times the derivative ng ln ng x, which is 1 over x plus ln of x, right, times the derivative of cosine x, it is negative sine of x. Ganyan. Medyo masalimot siya pero ito yung tamang approach sa pag-solve ng problem na to, no? So this will now become y prime over y equal to cosine x over x plus or minus sine ng x ln of x. So, ganyan lang siya. Then, meron pa tayong y, no? Hindi pa tayo tapos. Yung ating y ay ito. Hmm? Gagamitin natin ito to substitute dun sa value ng y. Ha? Ito, sulat ko. Ganyan. Therefore, we can say that y prime is equal to x cosine of x multiplied by cosine of x over x minus sine of x times ln of x. Right? So, yan. Ngayon, substitute na lang natin yung value ng 1 kasi yung pinapahanap sa atin, find the slope. No? At x is equal to 1, ano yung ating value ng y prime? Then yung pinapahanap sa atin. This will now become 1 times cosine ng 1, di ba? Times cosine ng 1 ulit, over 1 ulit, minus sine ng 1 times ln of 1. And of course, di ba, yung ln ng 1 ay 0 na yan. Tatandaan nyo yan. Okay. ln of 1 ay equal yan sa 0. Kaya magiging 0 na to. So, ano lang natira sa atin? It will be cosine of 1. Kasi 1 to the cosine of 1 is simply 1. Tapos, 1 naman to. So, mag-cancel lang yan. Therefore, yung value ng y prime is equal to cosine of 1. So, yun yung sagot natin. No? So, yeah. Napakagandang gamitin itong logarithmic differentiation, lalong-lalo na pag may mga exponent ka na parehas function. So, all you have to do is to take the logarithm ng buong equation na yun para bumaba yung exponent na function. Okay? Huwag na wag natin gagayahin itong general power formula kasi pang polynomial functions yan. Okay? So lastly, we are to find the derivative of a to the x. So wala naman siya pinagkaiba sa sa dito, e to the x pero yung kanyang base lang ay a. So dito, let's say we have y is equal to a to the x. Ibig sabihin ng a constant, kumbaga number 1, 2, 3, 4, 5, no? So ang gagawin lang natin diyan, logarithmic differentiation ulit. Ln of y is equal to ln of a to the x. Bababa ulit yung x. We now have ln of y is equal to x ln of a. So itong ln of a lumalabas na factor na lang siya kasi number lang siya, di ba? So parang meron lang tayong ln of y tapos meron tayong x. We can now get the derivative netong diretso na. So the derivative with respect to x ng ln of y is equal to the derivative with respect to x ng x ln of a, which is ln of a times the derivative of x with respect to x, which is actually also equal to 1. Therefore, ano ang derivative ng ln of y? It is 1 over y times the derivative of y with respect to x equal to ln of a times 1. No? Therefore, the derivative of y with respect to x is equal to y ln of a. In fact, yung value ng y ay a to the x, which is pwede nating ipalit dito sa y na to. Therefore, yung ating derivative with respect to x is equal to a to the x ln of a. So, ganun lang naman siya. Now, uh, yeah. Paano kung function ng u, no? So, to generalize, the derivative with respect to x of a to the x is equal to a to the x ln of a, right? And the derivative with respect to x ng a to the u, yung u is a function of x, it is equal to a to the u times ln of a times the derivative of u with respect to x. Let's try using this to this example. Uh, okay, so let's say we have f of x is equal to 9 to the x. Ganyan. Okay? So using this formula, yung ating f prime of x is simply 9 to the x times ln of 9. Di ba? Ganyan lang naman siya. Then let's try naman what if we have y is equal to 2 raised to x cubed. Ito medyo masalimot ng konti. Uh, let's say we have this u, no? Para mas ma-appreciate niyo. Let u is equal to x cubed. Diba? Ito na yung gagamitin natin ngayon. And du dx is equal to 3x squared. Kinuha ko siya kasi gagamitin natin dito yan. Therefore, y prime is equal to, gagamitin natin ito, a to the u, it is 2 to the u ln of 2 times du dx, which is 3x squared. Doon pala, pinalitan ko na. Palitan na natin. 2 to the x is 2 to the x cubed. Ln of 2 times 3x squared. Simplify natin. This will now become equal to uh, 3x squared or 6. No? Kasi, sorry, that's 3x squared times 2 raised to x cubed ln of 2. Okay? So, ganyan lang siya. Then, i-list out ko dito yung mga hyperbolic functions. Bihira naman natin itong gamitin, pero isama natin dun sa mga formulas na uh, kabisaduhin natin. Sa derivative with respect to x ng hyperbolic sine of u, sabi ng hyperbolic, ito may h dyan, equal yan sa hyperbolic cosine of u times du dx. Ganon din sa iba, no? Sa cosine naman, derivative with respect to x ng hyperbolic cosine of u, equal naman yan sa positive, no? Sine hyperbolic of u times du dx. Tapos sa tangent naman, derivative with respect to x of tangent, hyperbolic tangent of u is equal to, yes, secant hyperbolic secant of u du dx. Okay? So, sa cotangent naman, derivative with respect to x ng cotangent, hyperbolic cotangent of u is equal to negative hyperbolic cosecant of u squared. Okay? So, squared siya times du dx. For second naman, Derivative with respect to x ng second hyperbolic second of u equal yan sa negative hyperbolic second of u times hyperbolic tangent of u du dx. And for the derivative with respect to x ng oops, cosecant hyperbolic cosecant of u equal naman yan sa negative hyperbolic cosecant of u hyperbolic cotangent of u times du dx. So that's it. That's about it. Maraming salamat sa pakikinig. Hopefully meron kayong natutunan dito sa lesson natin. And dito, pag-aralan natin, pag-aralan ninyo, mag-practice kayong mag-solve ng mga exponential functions, logarithmic functions, and hyperbolic functions. This completes yung ating mga list ng functions. And on the next lesson, I will be discussing the derivatives ng mga inverse naman ng mga functions, inverse functions like inverse trigonometric functions, inverse hyperbolic functions. Okay? Maraming salamat at keep safe everyone.